Hi everybody, welcome. My name is Martin, I'm with Microsoft. I lead the development center here and also Skype engineering in Europe. And I'm going to talk about our quest for the holy grail of cross-platform development, because we set ourselves on an interesting path about 2 years ago. And I think it's something quite unusual, quite hyperscale. And I was thinking this might be interesting for you. But before I actually go and tell you that story, I would like to welcome you in this very building, which is the Microsoft Development Center in Prague. Surprisingly, not many people know that Microsoft has a development office here. And it's in fact one of the largest development centers in Europe. We have more than 350 people, engineers, PMs, designers actually working upstairs, and at this point they are kind of all hacking because we have a week-long hackathon called Fix Hack Learn in progress. So good stuff happening upstairs. If you are interested in what we build here, it's Skype, it's Microsoft Teams, which is a Teams collaboration tool, it's Dynamics 365 CRM, and most notably, it's actually a large chunk of the cloud infrastructure that is powering the communication experiences behind Skype and Teams. And we like to say that this is one of the largest Azure deployments in the world that we operate from here. And we're always hiring. So if you would like to see how it is to work for Microsoft, I encourage you to go to that career site that you see on the displays, or pay a visit to our wonderful recruiters in the booth outside, and they can actually tell you more about that. Now to the original story. Skype has a long history. Skype was founded in 2003, and we went through a couple of important milestones on the path of architectural evolution. In the beginning, it all started as a peer-to-peer network. And native clients were running on mostly desktop machines. The desktop machines were connected through quite reliable wired connections, and everybody was happy. But then a major shift happened in the technology, and that was the emergence of mobile networks. And then suddenly, peer-to-peer concept is not actually quite suitable for that, right? Imagine you have data of someone else pouring through your cell phone in your pocket. Probably not a great idea because of the bandwidth consumption, and also because of the battery consumption. So for the mobile world, we had to re-architecture. And at that point, we decided to re-architecture the backend services, the backend part of that. And we created a new set of hyperscale cloud services in Azure, and all the communication started to happen through that. But we still kept our native clients. We just made tweaks to them so that they, instead of the peer-to-peer stack, use the service-oriented stack. That was around 2012. And later on, we decided that we also need to touch the client code base. We were facing certain challenges there that I'm going to talk about. And we said, look, we need to do something about it. And ideally, it should be cross-platform because we want to achieve consistency and agility. So why? Imagine the architectures that we supported, or the platforms, right? It's iOS, it's Android, it's Windows, it's Mac, it's web. And you basically end up building 6 times the same. 6 different distinct teams are building the very same functionality. And if you want to release something, right, a new feature, then you probably want to release that on all those platforms at the same time, because you don't want to have a third of your users being able to do something and the others cannot even see it. And the challenge there was that our teams were geographically distributed. We have teams here, Tallinn, Estonia, Luxembourg, Redmond. We used to have teams in London, in Stockholm. And to kind of coordinate all of that was a hassle. And as a result, the time to market on certain features was really slow. We have a great example. Probably most of you are Facebook users, right? And back in the days, Facebook introduced one neat feature, and that is message reactions. Instead of just thumbs up, you can actually put emoticons there that express some emotion. Now, we had that feature in works way before Facebook actually released that, but exactly because of that, we were not the first ones to introduce that to the market. And that was kind of like a slap to our face. We said, look, this is not sustainable, right? We have good ideas, but we are unable to execute on them, so we need to change something. And lastly, there were subtle variances in the product. If you ask multiple teams to build the same, you rarely get the same. And so there were differences in look and feel, in certain behaviors, and most notably in telemetry. And if you want to know how your users are actually using your product, your telemetry must be super and very consistent. And that was an issue. So how did we approach the solution? We could have used some scaled agile process, right? Spotify, very famous process, and there are companies who are trying to sell you stuff like safe scaled agile framework. But we are engineers, and we are solving problems through code. So we said, look, we are good at that. We are going to solve this one through code as well. So what were we looking for? The solution, the dream solution that we were looking for had to fulfill some basic requirements. First, maximum code reuse across all the platforms, right? 6 platforms, not an easy thing. Ideally, all the developers should speak the same common language, and they should use the same tooling. We wanted to achieve the maximum agility. This is to be able to ship predictably, fast, ideally every week. And also, if there are sudden problems that somebody needs to look at, you can actually ask pretty much anybody, because you have an army of engineers who speak the same language and who have the same background, so they can hop on the problem right away. And another thing is fast experimentation. You want to try things, right? And you want to spend a week building that thing you want to try, because if you want to try something and it takes you 6 months to ship it, what's the point? And the consistency, that's what I talked about previously. Now, what were we looking for? In the market, there is many options that are available to address these problems. And one of them, the first one actually that we looked at, was to use some shared C++ core and build native UIs on top of that. That was very close to actually what we had there, but this was kind of more universal or more thorough shared C++ core. From the performance perspective, there is no question that is the right solution, but it didn't address our need to have the same code, or ideally as much shared code as possible also for web. It didn't address our requirement to have same framework and same tooling, and the code sharing options were limited, because there is actually quite a lot of logic living in that view model layer, in the top layer of the application. And Xamarin, right? Logical choice for Microsoft. Xamarin is part of Microsoft, so you would ask, why not use Xamarin? And Xamarin is amazing, but maybe more for enterprise applications. The code reuse is really amazing. Almost 100%, but at the time of this exploration, it didn't support web, and also it didn't address our need to have a client on Win32, Windows 7, 8. So that was not the right solution for us. HTML5, so build it as a web application, right? Sounds reasonable, and use Cordova or some other host on mobile. Perfect in terms of code reuse, addresses web out of the box, but the native look and feel and the perf on mobile is not quite there. So then we approach something that we call internally a scripted native approach. Right? UX is described in TypeScript, and there is shared logic, shared business logic as much as possible, and the UIs are rendered natively. Up to 90% of the code is actually shared, because only the native implementations of the controls or some specific things that really need to be native are native. There is a common language and common toolchain, because language is TypeScript and toolchain, pick one for web development. The drawback is that on the performance side, there was a little bit of an issue. But at the time when we did this investigation, we said, look, the devices that are in the market today, how is that going to look in a year, right? Every year the hardware is maturing, so even the cheapest phone with Android that you can actually buy in a year is probably going to be way better. And that was a pitfall that we fell into, because that is not true. Anyway, we chose this solution because it gave us the most green tick marks there. And this is kind of on a high level how our setup looked like. And it actually looks like this still, with some minor tweaks. React Native on Android and iOS. We actually use pure React Native. We have just one RN view, and everything runs in that. On web, we have React.js running in the browser, and on desktop, for all those platforms, is the same application, just hosted in an Electron container. Not sure whether you know Electron. How many of you have heard or know Electron? Yeah, few. There was a workshop, and there's going to be one more in the afternoon about that, if you're interested. The common code, really majority, and then platform-specific code. In case of Skype, is mostly about media and media encoding, media transport, so audio-video handling, because that needs to be real-time. And deep OS integrations, for example, share extensions and those things that touch the OS APIs directly. This is the high-level architecture diagram. Application code at the very top, that is the TypeScript code. That is actually the area where most of the development happens. So if you would become a developer here, that's where you would spend most of your time writing TypeScript code, and we use JSX to describe the views standard. Then there is that layer in the middle called React XP. There was a talk last year, Peter Lissy from Microsoft was talking about that. That is a framework that we built internally that is actually giving us that luxury of giving developers the time to write that upper layer, because it abstracts away all the differences between native and web, right? It exposes the same interfaces for the application logic developer and hides the platform specifics underneath. And at the very bottom level layer, there is React.js and React Native implementations for those different platforms. And a JavaScript VM, of course. The hard learnings. You would say, oh, this looks amazing, right? You just write your code, everything is running well. Now, nothing's come for free, actually. When we started adopting React Native, it was not as mature as we have expected. Yet there was a great, vibrant community around it, one of the largest ones and most active ones, so that's why we actually chose this framework. But still we had to do hundreds of contributions to the open source project, and also we are still keeping an internal fork of that framework with some private contributions that are addressing some particular needs that we have. And this is actually honestly slowing us down because we need to sync all the time. React XP, something that we had to build. We didn't think we had to, but we had to build, so that was non-trivial effort spent on that. And even Electron, right? You can actually get it from GitHub. It's maintained by GitHub, and you would think, amazing. It's a binary. I download it. I wrap my web app in it. Done. Maybe if you are a smaller company, that's fine. But if you are someone like Microsoft, where privacy, security, all those things are actually important because people are just waiting outside of the door to sue you for everything. We need to be very careful about these things. And so we started working with the Electron community, with GitHub. We became part of their steering committee to define what Electron architecture is actually going to look like. And we contributed several things into that code base, including Windows 7 desktop notifications, some other Linux-specific features. And the most expensive thing is actually maintaining Chromium up to date within Electron. Electron is a combination of Node.js, Chromium, and some other like Node modules and some other things around it. But Chromium is releasing a stable version every 60 days. Electron wasn't able to keep up, right? There was a 2-year-old version when we adopted that, and you can imagine that is full of security holes. We don't want to release anything with that, right? So we started investing into that. We built up an internal team, internal cadence to actually keep that up to date, and we are still doing it, and that is quite costly. And we are patching Chromium, and that is again related to our video stack, because in order to optimize the performance, we had to make changes into how video is rendered. Now another thing, and whoever stopped at our booth yesterday or the day before, lots of you are actually talking about performance and how that hasn't actually improved much. And PERF is complicated in this setup, right? It's an uphill battle. We made it super easy to write code, so anybody, right? Even if you are not a developer, you don't develop code as your main job. You happen to be, I don't know, some manager or whatever, like me. And there is a hackathon. It's actually fairly easy to set it up in an afternoon and go and hack something, and you have a feature that is actually ready to be experimented with that. It's very easy to write bad code, really, right? Because if you don't understand the internals, you can actually cause many of things that harm perf. React Native has this thing called RN bridge, right? You can imagine that as a asynchronous message pump that is actually connecting the two worlds, the native world and the JavaScript interpreted world. And it's sending events back and forth, And the design is actually pretty cool, and it doesn't give you much flexibility to alter how our message is prioritized, what to send first. So this can become a huge bottleneck for application performance. The JavaScript bundle, that's another important thing, right? When React Native starts up, it actually loads your JavaScript bundle. It's all the JavaScript modules bundled together, and it needs to load it in memory, parse it. And that takes time, and if you are not careful, you are actually not throwing away old code that is perhaps there, but it's not used. Application size is growing, startup time is growing. It's not great. Another thing we are fighting with are complex UI components in long lists. If you imagine any messenger, Skype, WhatsApp, Facebook, whatever, you have a conversation, it's a chat, it's an endless stream of chat bubbles, right? A chat bubble is not exactly a simple component, right? It has some message in it, it has some background, there's some actions, reactions, you can forward it and stuff like that. So it's actually made up of many layers. And if you have a long list, like I know thousands of that, then rendering becomes a hassle. These components are linked, and you can easily have too many re-renders, and then all the experience is kind of choppy and not pleasant. Another big thing that we are actually focusing on most of the time now is cutting the startup time. Startup time is important because if you are receiving a call, you can't wait 10 seconds for that application to boot up, right? That's, you know, the other person would give up. So that needs to be fast. But even, you know, if you are on mobile, you expect that to be instantaneous. And when we first released, that startup time wasn't great. And over the past few months, we actually managed to cut it by about 50%. And there are some things that we did. First, we are deferring JavaScript imports. I said there are, you know, hundreds or thousands of JavaScript modules that are actually loaded at the startup from the bundle. And if you just use the import statements, then actually you import modules that import other modules that import other modules, and kind of explodes into that. And you can spend seconds in just that. So we replaced imports with inline requirers. We have a Babel plugin that does that during the compilation time, and then many things actually are kind of happening just in time. Defer anything that you don't desperately need for application startup. It's almost good to think about what is my landing experience, what do I need to show, and then if you have stores or services that you don't need to init, just don't do it, because it results in a lot of I/O, especially if you have users who are running all the devices with slower flash storage. There may be local DB accesses that actually touch the flash storage. It results in a lot of traffic over the bridge, and in general, it costs you other precious seconds. Another interesting thing that we did was actually the move to ES6. We are compiling TypeScript now to ES6, and the runtime performance is about 15% better than with ES5. And this is an interesting thing. We are replacing the JavaScript core, which is the JVM with React Native on Android with V8. There is, again, a performance boost, and also it kind of makes your debugging environment, if you debug in Chrome, and your runtime environment consistent. Now let's talk about desktop, because that is important for our customers. We have a lot of users who are actually using Skype for professional use cases, like many of you probably in your companies, or to talk with your customers. And as I mentioned, we are using Electron, and Electron is great. And it's also great for simpler applications, but Skype is very complex, and especially for scenarios like group video calling, where you have 5, 10 video streams being rendered on the screen. There is a lot of tax that you need to pay to actually get those video frames from the media stack, which is running on a separate process, to the renderer that is running in Chrome. So that is causing the CPU spiking and battery life on laptops going down. Something very concerning. For us, another important thing was, how do we actually distribute Skype, right? Because we want to get it in front of as many people as possible, and we have the luxury of being part of Microsoft, so we can ship with Windows. But to ship with Windows is not easy. They are brutal. They are strict in terms of what they want from you, in terms of package size, in terms of battery consumption, CPU consumption, process model. And even though you can actually take Electron app or any other Win32 app and wrap it so that it looks like a UWP or store application, we just wouldn't pass those requirements, and Windows wouldn't let us ship with Windows pre-installed. So what we decided to do, we did bet on React Native again, but we decided to port it to desktop, right? And especially for the first thing was to port it to the UWP framework, so that we can actually use the same code base and generate an application that is actually a native UWP application. Took us about half a year maybe of a decent team to do that, but this is actually now shipping in production in Windows 10. And we are also looking at React Native on Mac. I have a small team here in Prague porting React Native from the iOS code base to the Mac code base. And if we look at some of the performance indicators, then what we see is actually up to 2 times faster startup time compared to Electron, and up to 50% less CPU usage in video call. And that is actually massive because if you are on the go, you can actually have a call that is 50% longer. Everything needs to be tested, and there is a cruel truth about validation. One line fix for pick your platform can break all others, right? Because it's one code base. And this is something that we have honestly underestimated a bit in the beginning. The thing is that manual testing doesn't really scale. You make a one-line fix, you think, hey, I've got a bug report on Android, you fix it, and then you don't test on all the other platforms, including tablets, including desktops, and you can really break things. And it's expensive to test it. So we are investing a lot into end-to-end automation. It's a UI level automation. It's a must, and for you the key message is please invest in it from the get-go, from the very beginning, because it's so expensive to catch up later. In the invite I promised that I'm going to talk about DevOps, and we are doing DevOps, but we are doing it for an application, which I think is not that common. Usually DevOps is connected, the term is connected with services, you operate services, you have a team on call, they monitor those services, and if there is something wrong, they get woken up at night and they have to fix it, and everybody loves it. But we decided to do the same for our applications as well, and the reasons are quite simple. We are actually releasing weekly. What you see in the stores or on our website is bi-weekly releases, but we are also releasing to insiders, which is kind of the people who sign up to receive dangerous pre-production versions. And those releases happen on a weekly cadence, and we release all the platforms at the same time. So for that, we need to be very careful, right? We release 1%, 5% of global audience at a time. And then we look at the metrics constantly as performance, reliability, and crashes. And if something goes wrong, we just stop the rollout, fix it, and continue, or we just continue by default. Now, what are the metrics? Could be message send time, right? It's important if you chat application so that your messages are sent quickly. Message send reliability, the same for calling, application start time, crashes. And then we learned the hard way that monitoring at the service level is not enough, right? We have backend services for chat calling. But what is true that the latency on an API doesn't necessarily equal the latency on the client. There are way many more factors that influence that, and that's why we have an end-to-end approach. The service team looks at their charts, we look at ours, and then if there is some incident or a risk, we work together to diagnose it. And even client developers have on-call rotations, so they can be woken up at night and go fix something. Speaking about the metrics, we have 2 big buckets of them. One is reliability, and second, based on volume. And they need to be treated differently because otherwise there would be a lot of noise in the alerting. The reliability metrics, we usually use some percentiles like P95 on metrics like message sent round trip time or some timing metrics. And we define static thresholds for them. So this is a real example. I just removed the numbers. But this is a real example of an incident that we had a couple of weeks ago where the message sent round trip time actually spiked. It was messages were sent too slowly. That crossed into the red threshold, which meant that an incident was automatically generated and somebody was called to actually come and fix it. Another type of metrics are volume metrics. Anything that is related to usage, number of messages sent, minutes that people spend on calls, number of calls, number of active users at a time. We track it, and these metrics are highly seasonal, right? There is variations throughout the day, throughout the week, throughout month and year. And if you would define static thresholds, you would just get noise and no meaningful signal because of all those variations. So we are using machine learning and anomaly detection algorithms that actually leverage machine learning. And what you can see on the screen over there is a real chart where you see the metric as a line, and then there is a band around it, which kind of denotes what is probable or usual band around that metric. And that little red blob there actually was an incident. It was an unusual behavior, and somebody had to look into that. So that's how we treat it. Now, that's probably all I wanted to say about the technical part. So one more thing I would like to ask you for. This Monday, we actually finally released the web preview of our new Skype client. It's built from the same code base. We just kept it as the last one to be shipped. So if you're interested, just go to preview.web.skype.com, and you can use Skype on web with the new design and with the new features. And that's all from me. So thank you very much.
Thank you very much for the talk. So you know the drill. Questions. There are a lot of questions now. Okay, so are you using Metro Bundler?
As far as I know, we don't.
Okay, that's probably.
Apple announced that they will enable iOS apps to be natively ported to Mac. Are you taking advantages of that on React Native Mac? We are actually porting the iOS implementation. Apple did a phenomenal job, by the way, in keeping those frameworks consistent. So that work is actually fairly mechanical. So we are not taking advantage of this, but we are actually re-implementing or porting what Facebook built for iOS.
Okay, let's do maybe two more. So what is the repository architecture like? A monorepo or a multi-repo?
We use monorepo for most of the things. Then some things that are not part of the core application are actually living in separate repositories. Like, for example, iOS native share extension is out. Then React Native and the frameworks are out.
All right, and finally, a question about testing. Do you use the same testing tools for all of the platforms, or do you need different tools?
This is an infrastructure that we actually have built internally. So it's kind of a test cloud-like infrastructure. There are different drivers plugged in. So you can write the scenarios that are common, but then the execution will differ based on what platform that runs on.
Right. So
all right.
Thank you again.
Yeah, I'm going to be hanging around, so if people have more questions or just want to have a coffee, I'll be somewhere outside. Thank you, and enjoy the rest of the day.